Hi everyone, welcome to my channel. This video is part of a playlist on AKS, Azure Kubernetes Services Networking. And what you see on my screen is a layered and reusable architecture diagram done using Draw.io. And I've created videos on how to create this diagrams. If you're interested in learning more, be sure to check that out. Again, all the content that is presented today is in my GitHub repo link below. So today's topic is Azure Application Gateway as Ingress controller. In short, it is AGIC AGIC. So we'll start with understanding the use case for Ingress controllers, key design points, and then we'll jump into VS Code and build the cluster from scratch. And while the cluster is building, we'll talk about core concepts and inbound and outbound flows. And then we'll deploy a sample application, run some validations from the command line and from the portal. And then we'll close it out with some troubleshooting tips. So let's get started. If you have been following along with me, our starting point is a brownfield environment. So in other words, we have an existing hub, existing spoke, we have a branch, and we have a site-to-site VPN between Azure and the branch. So a very classic hybrid networking scenario is where we start with. And I also, anytime you are looking at this, and this is the part that talks about the current topic and the CNI that is in use. So right now the CNI in use is the Azure CNI. And we've done other videos on the CNIs in general. So this AGIC lays on top of that video. So be sure to check that out as well. So let's start with what CNIs are supported first, and then we'll look at the use case. So if you check the Azure documentation, and I have put the links to this. Application Gateway as Ingress controller is not supported with CNI overlay, and that there is a link to that one. And of course, if you're using KubeNet, there is a special set of commands that you have to follow to do it in the KubeNet mode. So if you may want to follow this link right here. So with that, again, this one today we are going to be using Azure CNI, and as you can see with Azure CNI, both the node and the pod network are the same networks, and they are at the Azure at the Azure subnet level. Right, so 172.16.240 is an Azure subnet in Azure. So again, talking about the use case for AGIC, AGIC provides a layer 7 functionality. So you can do routing based on host header, URL-based routing, and you could do routing, multi-site routing, so host name-based routing using the same IP on the application gateway. So again, application gateway supports HTTPN, HTTPS, and SSL termination. So when you are using application gateway, your application gateway subnet can be in the same VNet as where your cluster is, or it could be in a different VNet. All right, so they are both supported. In this case, we're putting it in the same VNet. And so if you want an example of host name based routing, think of it like red.domainname.com, green.domainname.com, blue. They all land on the same application gateway, and the application gateway uses the host header to do the right routing to the right downstream application. Okay, and then we have path-based routing, and we'll go into a lot more detail where you could have a different URL path. So you can have app.domainname.com/red/green/blue, and that's URL-based routing. And remember that when we used the load balancer in the previous videos, it was used for inbound and for outbound. When you use the app gateway, typically you would want your HTTP traffic coming in from app gateway, and you would still use the load balancer for egress. Of course, there are other egress options, so be sure to check out my other videos on egress options. So with that, let's dive right into the VS Code, and we will deploy a 3-node cluster. So we'll deploy these 1, 2, 3 nodes. We'll deploy a 3-node cluster in the Azure CNI network model. All right, so let me bring you to VS Code. So here we are in VS Code. We'll clear the screen here. And let's go, let's just double check. Yep, so if you're following along with me, this should all look very familiar. I'm just going to verify that I'm logged in. I'm going to show that I have an alias. So let's do get context here. Let's clean up the existing CNI one. I was using that before. So, and let's run get context again. All right, cool. So this is all good. So let's set up the variables. Here you will see that the plugin we are using is Azure, which is Azure CNI. And you can set all of the other variables. I have mine already set and ready to go. So let's drop those here. And let's move on to create the resource group. Create the container registry. And we'll grab these VNet IDs and subnet IDs. So this, if you remember, and I'll show this to you in the portal as well, we'll just grab, these are existing VNet and existing subnet IDs. So in here, I have defined my VNet and my subnet over here, and they are in a brownfield environment, so it's an existing subnet and VNet. We'll create the identity, and then we'll grab this principal ID and this ID from the output. So we could do this. And so far, this is very similar to Azure CNI video that you have seen. So this one is where the application gateway comes into the mix. So I'm going to show you a few things before I run this command. So let's jump in the portal, and I'm going to show you all the existing configuration. So let's go to the portal here. Let me make sure I have my right profile. All right, so if I show you the virtual networks here, and we've been using this VNet. And if you look at the subnets, let's look at first AKS. Oops. Yeah, so we have this existing Azure CNI subnet. That's where we'll deploy the nodes. And we also have the AKS app gateway subnet that I have created. And this is where it will deploy the app gateway. An app gateway could technically exist in a different VNet, like I mentioned before. So app gateway subnet and CNI subnet, let's just verify that. So that's where the CNI subnet, and this is the app gateway subnet. Okay. Actually, I'm using, it says app gateway. So let's just make sure that we have that one here as well. So I have two, but we're going to be using app gateway subnet. So we're going to be using this one, app gateway subnet. That's what I have set it up. Maybe we should just fix this. I'm going to call this app gateway right here, just to be consistent with our naming. So we'll just use this one. Let me fix that real quick. Sorry about that. So we'll just call this app gateway. Okay. All right. So with that, let's set up all of these variables. Let's assign this network contributor role. And let's create the cluster using this. So the couple things to note which are different from the previous video is here you're specifying the app gateway name and the app gateway subnet ID that we just looked at. And you're defining enable add-ons, you're defining app gateway ingress. Other than that, all the rest stays the same. We're defining the max pods and a 3-node AKS cluster. All right, so let's go ahead and kick off the cluster build out. So this verbose is good. It echoes, it shows us more detailed output on what is going on. And so let's jump back into the Draw.io and look at the different flows now. So we just kicked off the cluster. It's going to have an IP in this. The nodes are going to have IP in this subnet, and the application gateway is going to have an IP. Let's put, just for the completeness, let's put this IP of the application gateway here as well, so we have an idea as to what. So I'm just going to copy this first, and we'll just put the application gateway's IP was 245 app gateway subnet, right? So that way, AKS app gateway subnet, right? So we'll just call this AKS-app gateway subnet. So we expect the app gateway to be provisioned in this subnet, and the nodes will be coming up over here. So what we'll do next is we'll deploy what's called this red, green, and blue service, and in a different namespace, and think of it as your apps, right? So red app, green app, and a blue app. Okay, and what we'll do is first we'll deploy these pods, and then it will deploy the service, and it service type this time is going to be of the type cluster IP. In the past, we did the one with the type load balancer, which was exposing it up at the load balancer level. In this case, we're going to be exposing it as an ingress controller. So we'll leave it at cluster IP, and then we'll deploy. And all of these are in a YAML file. So we'll use the YAML file to deploy first the cluster services, and then we'll deploy the ingress controller. Okay. And so what will happen is, the application gateway will have these different pods as its backend. In this example, I've drawn the lines for the red pods, and it will have this as the backend. Okay, and so when we will run all of these validations, but I'm going to show you first all of the high-level flows while the cluster is building out, and then it will do the same thing for the green and for the blue. So these would be the backend. And remember, App Gateway can directly access these pods because we are in the Azure CNI network model. And the output, the flow would look, inbound flow would look something like this. Okay, so let's zoom in. Let's make this a little bit bigger. So this user will connect This user will connect using the host header. Of course, you can use FQDN, but to test it out, we'll give a host header, and it will with the IP address, and you can specify the host header just for testing. In production, of course, you would want to map the FQDN with the IP address of the application gateway. So in other words, AKS colors.penguintrails.com will map to the IP or the FQDN of the app gateway. And I'll show you that in a little bit as well. So the typical flow would look like the user would connect to the app gateway will have a backend pool, and it will then hit the pod. So that's a typical flow. And of course, this app gateway is layer 7. So you have both the fan out and so a virtual host based routing, and also URL based routing. So in here, I am doing /blue. So that's URL based routing. I could do red, green, and blue. And here, the second one is host name based routing, where I could do red, green, and blue. Um, and they will all land on the application gateway. So let's take a quick look at if our cluster is provisioned, and looks like it is. So before we jump away from the draw IO, just want to show you one more flow, which is the outbound flow. And so the outbound flow is still going through the load balancer, and this is the same as before. Of course, you could do other type of outbound using firewall and NAT gateway, but for now we'll be egressing. The default is to egress through the load balancer. So those are the classic inbound and outbound flows, really straightforward. Let's actually now go and do some validations from the command line. And we'll first deploy an app, and then we'll do some validations. So again, let's get some credentials for the AKS cluster. Then we'll get the nodes. And if you want to see the network plugin, you can run that command. Good troubleshooting command if you if you are in a brownfield environment, want to know what plugin your customer has used, you can check that. And what we will then do is let's deploy an application. So we'll create a namespace called colors-ns. And let's take a look at this YAML files. So there are three YAML files for red, green, and blue. We'll look at one of them here. I'm just basically deploying a very simple pod. It's a HTTP echo pod from HashiCorp, and it's listening on, and I forced it to listen on port 8080. Okay, and it's going to spin up 3 replicas. And similarly, I would have a green pod, and a blue and a red, green, and blue pods. And simply, it's a very simple pod. It will just echo the text red to us if we connect to red, or green if we connect to green. All right. So let's look at now this. So we looked at the cluster IP, and you can see one more thing is we have 2 things inside. One is the deployment, and we also have the service. It defaults to the cluster IP. I don't have it here written here. If it was load balancer, we would see it. This service will default to cluster IP. So let's go ahead and kick off all the 3. So it's going to deploy red, green, 3 replicas of red, green, and blue pods, and then we can just do a kget command to see what we have. So right now we don't have Ingress, so let me remove Ingress. All right, so let's take a closer look at this output and understand this. So the first, we'll start here. So these are the nodes. As you can see, this starts with the nodes. And nodes got an IP from 172.16.240. And these are the pods. So you could see that 3 blues pods, 3 green, and then we get 3 red. Okay, they all got an IP from 172.16.240 going back to the drawing board. This is the network where they got the IPs from. Okay, and the service is exposed as the type cluster IP. In the previous videos, you would notice that this was the load balancer IP. So service is exposed still within the cluster. So now let's look at what the ingress.yaml looks like. Now these are Ingress. So if we look at, there are two types. I have fan out and virtual host. Let's understand the difference. What is a fan out? So fan out is something like this. If you connect to AKS colors.penguintrails.com, you can do /red, /green, /blue. So essentially it is URL based routing, but you still connect to this host. Okay, and the virtual host is you have different host names. So it's a host name based routing, AKS red, AKS green, and AKS blue. Okay, so what we will do is we'll deploy two, and if you see the kind is Ingress, an Ingress class name. So you could have an Nginx Ingress controller as well. So here we are specifying the Ingress class name to be application gateway. So that's important. So the class name here is application gateway and it's of the type Ingress. So let's go ahead and deploy that. So we have the fan out and we have the virtual host. So now let's describe, first we will run some validations from here, from the command line, and then we'll go do a detailed look in the portal. So all the things that we see here will also be visible in the portal. So let's look at the pod services nodes, and then this time we will add ingress. Let's reverse the order of nodes and pods so it looks in the right order. Nodes, pods, services. Okay, so if we look at this output, oops. Let's expand this so we can see the whole thing. So we have the 3 nodes, we have the pods that we looked at, the services that we looked at, and then this is the new thing, right? This is the 2 ingress controllers that we deployed. So one is of the type AKS colors.penguintrails.com. This is where we're going to do the /red, green, and blue, and this is the one with the virtual host. So let's take a closer look at that. And this command actually shows it much, much better. So let's look at the describe command. I've shown this command before. So we'll first look at fan out. So let's clear the screen here and we'll look at fan out. As you can see, we can hit it on akscolors.penguintrails.com with the /red, green, and blue. And then this one, so we'll clear this. And of course, before I move away from here, you can see that it first goes to the cluster IP and then the backend. These are the downstream different pods that are listening on port 8080. Okay, so that's for that one. And then let's look at the virtual host. So virtual host, let me clear the screen first so you can just see the virtual host. So the difference between the virtual host and the fan out is that this one has different host name. Okay, and they still go to the same service, red, green, and blue, and the same pods, but the way you address them or the way you reach them is through the app gateway is different. So we'll do a quick test. We should be able to hit it on the application gateway IP. However, one thing to note and I stumbled upon this a couple times, is we still don't have a public address. That means it's still not fully provisioned. So we have to wait till we get an address gets populated over here. And same thing for our, let's gonna look at the ingress as well, the fan out as well. We're still waiting on the address here. Okay, so while we're waiting, let's go in the portal and I'll show you a couple of other things. So we'll start with the Kubernetes service. We'll open it in a new tab. And we see that this one is provisioned. If we go to the resource group, we see some of the services that some of the resources that we already provisioned, but we don't see the app gateway. And why is that? It's because we need to go in that special resource group. If you remember from the previous videos, the MC underscore resource group. So let's find that. So I'll just search for AKS here. Let's go to the MC underscore, and there we have our application gateway. We called it My Application Gateway. And now we do see the IP over here. So our command line should show it as well. Let's run it one more time. Yeah, okay, so this one is still not fully provisioned, so we still don't have an IP here. All right, while we wait, let me show you. Oh, there we go. You can see here that it's updating, right? So when it's updating, you will not see the IPs yet on the command line. So let's double check a couple of other things. So in this configuration, you can see that mm, the application gateway has the public IP of 15, and let's take a look at this one's not completed, so we'll wait for that. In the meantime, let's look at this connected devices over here and see what we can see in the AKS pool. And so here in AKS, if you remember with the CNI, it allocates this 30 pod IPs ahead of time. So that's what you're seeing over here. And if you want to see the app gateway, it has assigned an IP to the application gateway for us in that subnet. This is for it to reach the downstream services. So let's check our thing again in the command line. We are still waiting. I'll pause the video if it takes longer, but let's finish up our other thoughts over here. So one of the things I did want to show you a little bit later as well is I have documented all of the outputs over here. So so you don't need to spin up the cluster. So it's all in one draw IO file, and I also have all of the output for all the commands that you see, the fan out and the virtual host and the fan out. So this one is for virtual host where you could see red, green, and blue. And this one is for URL based routing, red, green, and blue. So all of these are documented should you need to review it, and they all match the IPs that are shown over here. So with that, I'm going to go back into the portal to show you the DNS bits a little bit. So let's run this command one more time while we wait. Still provisioning. So I'm going to show you this FQDN based routing that I mentioned. So what you have to do to kind of have the FQDNs set up correctly is you will map this front end IP, this IP of the load balancer to something called, and let's do that while we are here, is if you go in the configuration, we will map this to an app gateway. And then I will go to my domain, my penguintrails.com domain, and I will have a CNAME for those pointing to this one. Okay, so let me show you that. Let me bring that up again. Um, the FQDN part. So let's go ahead and save this. And the way it looks on the DNS zone is something like this. So I'll show you the record for DNS here. So let's look at AKS. All the AKS records. So if you look at the AKS red record, and if I hit edit over here, you can see that AKS colors.penguintrails.com is mapped to that DNS name that I just created on the app gateway. All right, so this is a CNAME record. That's how you would do it. And it's going to go to the app gateway that we just created. All right, and same way, AKS red, green, and blue. Let's just look at one of them. And the same way, AKS red is mapped to the app gateway. Okay, so that's how you would set up the CNAME record. Some people put IP address, but best is to put best is to create a DNS record and use a CNAME record over here. So in other words, on the app gateway IP, you can put a DNS label, and then on your end, in your DNS zone, you can create a CNAME. So that's how I've done it. Let's take a quick look at this one. It does take some time to provision. There we have the IP now. So we will just fix this IPs everywhere. So we will just replace this. We can place all of these here with the new IP. I have the old IP from the time I ran it before. So we'll just fix these and run these commands. So now the moment of truth, let's validate our fan out first. So here, like I said, this is a quick test. So we're giving a host header. And we will also validate it with the FQDN. So let's clear these screens. And you can see this /red gives me red, /green gives me green pod, and this should have been blue. So this /blue should give us blue. And same way, this is the virtual host. So we're going directly using this host name. So you get red, green, and blue. And because we already fixed the FQDN should work as well. So directly calling this using FQDN should work as well. So all looks great. And then let's just test this with this as well. So this is using the FQDN, and this is how you would typically do it in production. All right. So now let's look at some of these in the portal now that it is deployed. So we'll look at how the app gateway side looks in depth on the portal. So we'll start with the front end IP. Front end IP, as you saw, was 92.15. And let's look at the listeners. So it created a few listeners, and you can see that they are multi-site listeners. So if we go in one of the listeners, which this one is a multi-site listener, and it has that colors.penguintrails.com. Okay, and this is the one with the URL path-based routing. And then we'll look at one of them, red, green, and blue, and we'll look at one of them. It's also a multi-site, and this honors the host name aksred.penguintrails.com. So this is how, application gateway has only one front-end IP, but this host name does the trick of mapping. And so next we will look at the backend pools, and it has created three backend pools. So we'll look at the red backend pool. They're all the same. And if you look at these target IPs, 35, they're all in the 240, but 35, 64, and 77, they should match with the red. So let's run this command one more time. So the red ones, they should match 35. So 77, 35, 64. The last octet matches the red pods. So going back on the portal, 77, 64, 35, 77. Yeah, that's it. So that's the red. Similarly, we have the blue and the uh, green backend pools, and you'll see that the backend health is also checking on port 8080. And lastly, we'll look at the rule. So first we will look at the one, this one where you were looking at this is the red, green, and blue. This is the host name-based routing, and you can see that this is targeting the blue service. And if you look at this one, the one that says path-based, this is the one where we are doing, if you look at the backend targets, we're doing /red says green /blue. Okay, and it goes to the corresponding services. And this was all orchestrated by that YAML. We didn't have to do anything. So again, we can check other services, and the backend service in this case is red, and then this one is green. Okay, so we have three rules. So that shows everything that you need to see. You can check the backend health, and they all look healthy. They all look healthy over here. So this is a good test to do. And finally, I just want to show you a couple more things here before we close out the session. You know, I've put a couple of troubleshooting tricks over here. kget events demo-ns. Oops, this should be colors.ns. So this is the namespace we're working with. It gives you valuable information there, and you can verify DNS. We've done this in the previous videos, but they're all here. And finally, you can delete this resource group to clean up everything. So with that, let's look at the flows one more time and close this out. So again, the end-to-end would look something like this. The user comes in, hits the app gateway. App gateway directs it. So number 2 here. So I have numbered these. You can see number 1 is it hits the app gateway. Then it from app gateway it goes to the node, and then from there these are exposed directly on the node network, so goes to the node network and then finally hits the node. So this cluster IP is still in use for in-cluster operations. And then again, the outbound is using the app gateway. Of course, there's a lot of magic that happens, and the requirement for cluster IP within an AKS cluster, there's a lot of IP tables magic that happens. But at a high level, this is how the flow happens from app gateway to the backend pods. Thank you again for joining me. I hope you enjoyed this session. Drop me a note, a comment if you'd like to see more videos like this, or if you have a specific networking topic that you would like me to cover. Thank you.